Guys, in this video we're going to be talking about the periodic table, and so we're going to go through the general structure of the periodic table, and we will talk about the different parts and their names and so forth. And so here we want to get familiar with the periodic table and know the different parts. So the periodic table is the primary tool that chemists use to describe chemistry, and it provides a systematic description of the elements. The elements are arranged by increasing atomic number, that is, as the number of protons within a given atom increase, the atoms are listed in that order. The atoms are folded together into different groups that have similar chemical properties. You'll see the structure here in a second or two. A group or family, as they're called, represent a column of the periodic table, and then the different rows of the periodic table are called the periods. The periodic table is divided into three different groups, and I'm going to go ahead and pull up the table here so that we can see the different groups. So here I've got my copy of the periodic table shown for you. Generally speaking, we can classify the elements in the periodic table as being metals, nonmetals, and metalloids. Okay, so the metals are all of the, so I'll draw your attention to these gray, lightly shaded atoms in gray. These are called the metalloids. Okay, and the metalloids separate the metals, which are on the lower left of this staircase, from the nonmetals, which are on the upper right, with the exception of hydrogen, which is also considered a nonmetal. So lithium, beryllium, sodium, magnesium, aluminum, potassium through gallium, and all of the rest down here below the metalloid staircase are considered metals. Hydrogen and everything to the upper right of the staircase are considered to be nonmetals. Metals have the characteristic of being lustrous, that is, they are shiny. They are malleable, which means that you can hit them with a hammer and deform them. Many metals are very ductile, which means you can stretch them into wires. Metals are good at conducting heat and electricity, and under normal conditions, most metals are solid, the one exception being mercury, with the atomic symbol Hg, which is a liquid at room temperature and atmospheric pressure. Nonmetals, on the other hand, they're kind of the opposite. They are not shiny. They are dull-colored. They look basically like rocks. They're hard, and they're brittle. So when you hit them with a hammer, they don't deform. They shatter. Generally speaking, they are poor conductors of electricity and heat. They are either gaseous, so the element hydrogen and the elements here on the right and many of the elements in the upper row, also including chlorine, are gaseous. The other ones are solid. There is one liquid nonmetal, and that is bromine. Bromine under atmospheric conditions is a liquid. The metalloids are in between the metals and the nonmetals, and likewise their properties are in between that of metals and nonmetals. Importantly, the metalloids, especially silicon and germanium, are known for their semiconducting properties, which means they can be turned on and off again like a switch, which makes them very useful in electronics. And so there's a very large industry centered around silicon and other semiconducting metalloids. So you want to be able to distinguish metals from nonmetals and metalloids. And this is an important point. It's going to come up a lot throughout your general chemistry experience. And so you definitely need to know the difference between metals and nonmetals. In this next sequence of slides, we're basically going to be going through the different parts of the periodic table and associating the different groups with names. And so we'll go through all of these, and in fact, on the next slide, we have all of these listed, but it actually shows them on the periodic table. So this structure here lists the different names that we need to know. So first of all, I'm going to start with the main group elements. So the main group elements are those that are here on the left, groups 1 and 2, which you see, as well as groups 13 through 18. So they're shaded in green. So all of these that are shaded in green are referred to as the main group elements. So the two columns on the left, and then these other columns here on the right. Those are the main group elements. Down here in this sort of tan color, we have the transition metals. Okay. At the bottom, we have the inner transition metals. The upper row is called the lanthanide series. The lower row is called the actinide series. Going back to the main group, group 1 are called the alkali metals. So that is going to include lithium through cesium. Group 2, these are the alkaline earth metals. This would include beryllium through barium. And then over on the far right-hand side, we have the noble gases. Sometimes these are also called the inert gases because they do not react very much. In the next row over, we have the halogens, so fluorine, chlorine, bromine, iodine. These are all known as halogens. The oxygen family are called the chalcogens. The nitrogen family are called the pinctogens. And I believe that the carbon family are referred to as the tetragens, and the boron family are called the icosagens. However, I've double-starred this because these terms aren't particularly important, but everything else you definitely need to know. So you need to know all of these names and what portion of the periodic table they correspond to. Here, this exercise is meant just to play around with the periodic table. So listed are different atomic symbols and different atom names, and you are instructed to figure out whether the substance is a metal, nonmetal, or metalloid, and then if there's any important name, you should label that, and then you want to identify the group number and the period number to which these particular atoms involved are assigned. And so we'll start with Se here. So that is the atomic symbol for selenium, which we find right here. It's in group 16. It's also in period 4. I want to point out that I'm using two different group numbering systems. Okay, the Arabic numerals 1 through 18 are the IUPAC official group numbers for the different groups of the periodic table. The Roman numerals with the letters, these are the North American group numbering system, which is older, but it also has some utility as well, so I've included it. You'll notice that the main group elements, so the first two columns on the left here, and the columns on the right, they all have the Roman numeral followed by the letter A. And so the main group elements in the North American group numbering system, they have an A next to the number. You see that the transition metals all have the letter B next to them. So I've provided them both, both the IUPAC and the Roman numeral North American group numbers for us to look at. So selenium is in group 16 or group 6A. It's in period 4. We see that it's above the staircase, so it's a nonmetal, and it's part of the oxygen family, so it's considered to be a chalcogen. Cesium, part B here, the symbol CS corresponds to cesium. It's in group 1, group 1A. Period 6, it's an alkali metal, and it's part of the main group. Iron, Fe, is the symbol. Iron is the name of the atom. It's a transition metal. It's in group 8 or group 8B. Don't think I have anything else to say about it. Copper, another transition metal, group 11 or group 1B. It's in period 4. Bromine. Bromine is a halogen, period 4, group 17 or group 7A. You get the idea here. I'll go ahead and leave the other ones for you as an exercise, but this is something that you need to be able to do. You need to be able to use the periodic table to find atomic symbols, to find atomic numbers. You need to be able to know what the group numbers are, what the periods are, and you need to know the different parts of the periodic table that we've gone through. Okay, so these are all essential things for you to be able to do. I encourage you to utilize the end of chapter questions, which have you go through similar exercises to these for other atoms within the periodic table, and that's going to help you get to know how to use the periodic table. So really, the best way to know the periodic table is to use the periodic table. And so with that, I'm going to go ahead and stop this video, and we'll pick up on this next topic in the next video.